All right, in today's lesson, it is really truly just a continuation off of the last lesson that we just did. So we're going to be doing a lot with combinations, except now we're going to involve when you're finding the probability or dividing by. So very similar to the last lesson though. So the first question says you're dealt 5 cards from a standard deck. That just means it's out of 52 total cards. What's the probability you're dealt 3 hearts? So this first piece, the 3 hearts, we're going to set up like this. We're going to say there's 13 hearts total and we're choosing 3. Again, this is a combination problem because it doesn't matter what order the hearts are in. And then the next part says 1 spade. So I'm going to say there's 13 spades. We're going to choose 1 of them. And then 1 card that's not a heart or a spade. So basically, if there's 13 hearts and 13 spades, there's also 13 diamonds and 13 clubs. There's 26 cards left over, or half of the deck left over. So we need one of those 26 cards that's not going to be a heart or a spade. And that's where that part's coming from. Now again, this problem is asking for probability. So we're going to have to deal with this a little bit differently. We have to divide by something. So I want to divide by the total number of cards. There's 52 cards in a deck. And the total number that we're choosing, which is going to be 5. Now, as I put these in my calculator, I'm going to do them separate. So right now, I'm just putting in my calculator 13, choose 3. And I get 286. We know that 13 choose 1 is going to be 13, and 26 choose 1 is going to be 26. And 52 choose 5 will be 2,598,960. I was looking at that wrong. So I'm just going to put in those last steps by multiplying everything in the numerator and then dividing it by what I had in the denominator. So I get 0.037 for the probability. Only new part here, because we worked on all of this in the numerator on the last lesson, so the only new part here is dividing by. So in this one is a marble problem. We had one of those in the last lesson too. A jar contains 8 red marbles, 3 blue marbles, and 4 yellow marbles. If 6 marbles are selected, what's the probability that 4 are red? So first of all, we remember that there's 8 total red. We want 4. And 2 blue. So there's 3 blue marbles, and we want 2 of them. Okay. And then just remember that we're always going to divide by 2. Since it asks probability right here. All right, so what are we going to divide by? How many total marbles were there? 8 plus 3 plus 4. So it looks like we're looking at 15 marbles. And we're going to choose, it looks like we chose 6 of them. Okay. So I'm going to put the numerator in to my calculator. And I get 210 for the numerator. And then 15, choose 6, is 5,005. And then I'll divide those two. I get 0.042 if I were to round it. Okay, all done with that one. Now these problems I'm going to go a little bit slower on. These ones usually get kids a little bit confused because there's some moving, or there's just some different parts to it. So when we're trying to find the probability that something's defective, is we're going to first of all find the number of ways to choose a defective one, or how many defective they want out of total defective. This will make more sense when we actually start just going through this first problem. It says Best Buy gets a shipment of 75 TVs, and 4 of those 75 TVs are defective. What's the probability that one of the first 10 is sold as defective? Okay, so first of all, when we look at this, I think it would be easiest to look at what's going to go in the denominator first. There's 75 total TVs, and we're choosing the first 10 that are going to be sold. That tells us the total number of ways we could select 10 TVs out of the total 75. We don't care if they're defective or not, it's just the total. So now we have to talk about defective versus non-defective. So I'm going to write this part in red. The defective parts are going to be in red here. So there's 4 defective TVs out of the total 75. And how many do we want? Well, we want one of the first 10 to be defective. So we want to choose one of those defective TVs. Sounds weird to say that we actually want a defective TV, but what that means then is if there's 4 defective TVs, it means that 71 TVs are not defective. I'm taking the total minus the 4 that are defective. So I have 71 TVs that are not defective. If I want 1 to be defective, then I want 9 of the 10 to not be defective. Now let's just go through that one more time because I want to make sure it's really clear. This is where we're getting it to add up to be the 10 defective TVs. Okay, we have 1 defective, we have 9 that aren't for a total of 10. Then when we look here, this is the total number of TVs altogether. 4 defective plus 71 that are not equal a total of 75. Okay. So now what I have left to do is to put the numerator in my calculator. And the numerator ends up being something really large. 2.97 times 10 to the 11. Yikes. I'm just going to leave that number in my calculator and hit divided by 75, choose 10. So that I don't have any round off error. Okay. So I don't know what the bottom ended up being, but when I divide by it, I get 0.359. And that's my total. Okay. I believe this is our last process, so I'm going to go nice and slow. This is another defective one. So it says a business receives 120 printers and there's 3 defective. If John takes 5 printers to a different office, what is the probability he takes 1 defective printer and 4 non-defective printers? Again, let's just set up the denominator first. How many printers are there? There's 120. And how many is John taking? He's taking a total of 5. The denominator is not affected by the defective and non-defective. Then I'm going to do defective in red again, okay? So we know that there are how many defective? 3 of them are defective. And John's going to be taking 1 of them, the defective printers. That leaves 117 printers that are not defective. And we need John to end up with 4 that are not. So again, for these pieces here, all of these add up to be 120, and that's the way you see it down here. And these numbers add up to be 5, and that's what we see down here as well. So again, I'm going to put that in my calculator. This will probably be a big number. Yeah, it was right here. So I'll write this number down, but really what I'm going to do in my calculator is keep all of it in there and just hit divided by it. I'm going to do 120, choose 5. And so I end up with 0.117 for the probability. So my advice would be on these defective ones, set up the denominator first. Okay, like the total, because you don't have to worry about defective or non. Then I'd say how many defective do we want out of the total number that are defective. And then lastly, calculate the non-defective. Both of these go in the numerator. This is a type of problem that many kids struggle with, so if you need any extra help, please reach out. Here, yeah. And there's a couple of quick statistics on the last page here. Probability of winning the lottery is 45 million to 1, and probability of being struck by lightning is 300,000 to 1. It's kind of ironic.